Today on the Woken Way, we're going to be doing 4.1, which is just angles and radian measure. So we're going to start with just some terminology. So what you need to know first is this is the initial side of every angle. We don't really graph it very often, so you won't really have to do it, but that's the initial side starting at 0 degrees or 0 radians. And then the angle is going to be rotated a certain number of degrees. And then this ray right here is the terminal side. So later on in this chapter, it's going to say with the terminal side of theta or something like that. That just means like where the angle ends up, which makes sense because it's terminal, which means end. So a couple of things you need to know. If you're graphing a positive angle, you're going to start from 0 and go counterclockwise. So that's kind of just saying go up. And if you're graphing a negative angle, you're going to go clockwise, which means that you start from the initial side, which is 0, and go down. One other definition is the quadrantal angles. So 90, 180, 270, and 360 are all quadrantal angles because the terminal side ends up on the x or the y-axis. So right here we have a little note to fill in the degree measures on the unit circle. So you're going to get this out right here. And we're going to start by starting with 0. And I'm just going to zoom it down a little so we can see the whole circle. Just about the whole circle. Let's move this up. Okay, so you can see there's some other things labeled on here. We're not going to deal with those just yet. We're going to start with this right here. This is 0 degrees. If I go up here, this is a right angle. So this is 90 degrees. And what I like to do is count by 9s and then add a 0. So 9, 18, add a 0, 27, add a 0, and then this will be back to 360. So if this is 90 degrees and this piece right here that's bold bisects 90 degrees, this would be 45 degrees. And if this piece right here and this piece right here take and divide 90 degrees up into thirds, this is going to be 30 degrees, and then add 30 would be 60 degrees. So we're just going to go ahead and label all the way around the unit circle. 120 degrees, 150 degrees. This would be 135 degrees because 90 degrees plus 45. Let's get those 45 degree angles in there first. That's 225. And then over here is going to be 315 degrees. And then we'll go back now and fill in our 30, 60, 90 angles. So we have 210 degrees, and then we have 240 degrees, and then we have 300 degrees and 330 degrees. So the reason why we're only graphing these angles on this right here is for something that we're going to use later on in 4.2 and 4.4. So you should have all those labeled. That's nothing new. There's 360 degrees in a circle. Half would be 180. Half of that would be 90, and so on and so forth. Okay, so now we're going to move back to our notes, and what we're going to do is go to the first example. So the first example tells us to go ahead and draw the angle. So you can see that I have these little what they look like giant plus signs, but they're really like an X and a Y axis, but we're just going to impose our angle on it. So if you're asked to do 225 degrees, most of you guys know this is 180 degrees and this is 270 degrees, and then how much past 180 is 225, and if you can't do that in your head, just use a calculator. It's going to be 45 degrees, which means the angle is going to come around here and bisect this quadrant right here. So it looks like that. Negative 100 degrees, this isn't one that we just graphed, but we're okay. This is negative 90 degrees, and this would be negative 180 degrees. So how much past 90 is negative 100? It's 10 degrees past, and I am going to rotate clockwise, because you can see that's what tells you that, because it's a negative angle. 487 degrees is super annoying, but here's what I do. I go 9, 18, so like 180, 27, 36, 45. This next one would be 540. So I'm just doing the math fast, taking a shortcut. So how much past 450 degrees, which is where this is 450 degrees, and this is 540 degrees, is 487. It's 37 degrees, so a little over a third of the way. And it's kind of fun because it starts to make the little spiral like a snail's shell. Okay, next definition we're going to go over is the unit circle. The unit circle has a radius of 1. So this is super important right here. We use this for almost the rest of the term. So you got to make sure you know this. Its center is 0, 0. So if I do draw that on here, this right here is 0, 0. And then the points, because it has a radius of 1, this would be 1, 0. And then up here, this point right there is going to be 0, 1. Then we have negative 1, 0, and then here we have 0, negative 1. So you're going to want to make sure you realize that. So we're going to use it again later in this chapter. So the next note says that we're going to go back to our unit circle, our big unit circle, and so we are going to go ahead and fill in the radian measures, which is sometimes harder for students. So we're going to take our time with this one just so that we can make sure that we're clear on what needs to happen. So the radian measure part I'm going to do in pink pen. So first we have to start with, we're actually going to flip it back over. I just want to fill this out real quick so it makes sense to you before we do this next piece. What's the formula for circumference of a circle? 2 pi r. And in this case, because it's the unit, like 1 unit, the radius is 1, so the circumference is 2 pi. And that means one trip around the circle is 2 pi. Remember that area is something different from circumference. Circumference is perimeter for circles. So back to this. What we know is that if we're on the unit circle, one full trip around the circle is 2 pi. So it's still 0, but it's radians, and this is 2 pi, like that. So with that said, if I only go halfway, then this over here is just pi. So we have pi and 2 pi. So now a half is a whole, which is super weird for us, but I'm going to be drawing some little things up here to help us in a second, but this is a half of a circle, which is actually 0 to pi, which is going to be helpful in a second. So before we get to that piece, if this is pi and I cut it in half, then this right here is pi over 2. And one thing that has helped students in the past is if you take away the pi temporarily. So if I said one trip around the circle is 2, what's half a trip? And then you would say, well, 1, and then you just throw the pi on, 1 pi. If half a trip around the circle is 1, what's only a quarter trip of the circle? Well, you'd have to cut 1 in half, so it would be 1/2, so that would be pi over 2. So I have 1 pi over 2, and then if I add another pi over 2, that gives me 2 pi over 2, which simplifies to pi, and then if I add another pi over 2, I'm down here, and this is 3 pi over 2. And if I add another pi over 2, that would be 4 pi over 2, which simplifies to 2 pi. Alrighty, so next we're going to now cut pi over 2 in half again. So remember, this was 1, and then this is a half, and if I cut it in half again, I would get a fourth. So all 45-degree angles are some factor of pi over 4. So that would be a 1/4. So watch how this breaks down. 1/4, 2/4. So do you see that shaded circle right there? 1 equal piece, 2 equal pieces, 3 equal pieces. So 3 pi over 4, 4 pi over 4, and then we're getting down to the bottom half. This would be 5 pi over 4, which is 1 1/4, so 1 and a fourth. 6 pi over 4, 7 pi over 4. So those are the 45-degree angles, but we still have some angles left. We still have these guys right here. These are the dashed lines. They're supposed to make it easier. I don't know if they actually do, but what I want to show you with those is first I'm going to start by cutting half of the circle, which is a pi, into thirds. So this would be pi over 3, and this would be 2 pi over 3, and then that would be 3 pi over 3. So 3 equal pieces. This is kind of annoying because it's right in the middle, but if I want to look at those 3 equal pieces, I have this equal piece right here, and then I have this equal piece with this, and then I have this equal piece with this one right here. So you can see those 3 equal slices. And since there's 3 of them, they're pi over 3s. So this first one right here, this first piece would be pi over 3. 1 pi over 3. We're going to skip this because it's not one of the equal pieces. This is 2 pi over 3. Then we come all the way down here. 3 pi over 3. You got to get that next equal piece, so those are larger pieces, so it's going to be down here. 4 pi over 3, large piece, 5 pi over 3. So the only ones we have left are these little 30-degree angles. So they bisect all of those 60-degree angles. So how many equal pieces do I have now? I have 6. So one little sliver is 1/6, or pi over 6. So this is pi over 6. 1 pi over 6. If I go to the next sliver, it's going to be 2 pi over 6, which is right here. Sorry. Yes, 2 pi over 6, which reduces to pi over 3. Then I get up here, 3 pi over 6, which reduces to pi over 2, 4 pi over 6, then 5 pi over 6. So the small slivers are 6 because they're smaller slices of pizza. 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and then 11 pi over 6. So that's all the radian measure. So again, what you have to remember is that when you saw something like this in elementary school, and it said, write the fraction. For this right here, in elementary school, you would have written 1 and 1/4 is shaded because technically this is here, right? But in terms of radians, that's not 1 and 1/4. In terms of radians, that's 1 pi, 2 pi, and then half of pi. So it's double what you would normally expect, okay? So that's what our radians looks like on the unit circle. So let's go back to the notes now, and we're going to go ahead and draw these in and continue with the rest of the lesson. So right here, 3 pi over 4. So when you do 3 pi over 4, what you're going to do is keep in mind, I'm just going to draw these just for this lesson. I want you to label this. This is pi, but another way to look at it is 4 pi over 4. So that's where you get a full 4 out of 4, but we don't have 4 out of 4. We have only 3 out of 4. So it would go from 1, 2, 3. So I'll show that over here. 4 equal pieces, and you have 3 of them. So it should be bisecting the quadrant 2. Okay, this one right here, what you might want to do is write it as 1 and 1/3 of pi. And since this has a denominator of 3, I'm going to write this as 3 pi out of 3. I'm asked to graph 4 pi out of 3, so I'm going to be bigger than that. So if I look at this, it's going to go, here's all the way to 3 out of 3 pi, and then I actually need another one because it's 4 out of 3. So I'm going to divide the bottom half of the circle, into 3 equal pieces, and I only need to go to one of them, so it's going to be right there. For the next one, negative pi over 7, that's weird because it's sevenths and it's negative, so I'm going to be starting down. So this would be 7 pi over 7. That's just going to help me. That means I would need to divide this into 7 equal pieces, which isn't super easy to do. 1, 2, 3, 4, 5, 6, and 7, hypothetically. You don't have to do this every time, you can just eyeball it, but it's going to go ahead and go like that right there. So it's been brought to my attention that some people aren't working on their notes, or they're just pausing the video and not listening to the video. So right now, if you're listening to this video and you want to earn some extra credit, go ahead and put a star up by your name, and tomorrow when I check your notes, I'm going to go ahead and give you extra credit as long as I don't hear you telling other people, because I actually want to get accurate feedback on who actually is listening to these notes. So for this one right here, we have, I'm going to put this as 19 pi over 19. This is negative 1 and 1/19. That's a little bit easier for me to see. But over here, this is going to be, sorry, I'm making those negatives just because of what we're doing. This is negative 19 out of 19, and I need just one sliver more. So I'm only going to go just a tiny bit more, and it would look like that. Okay, coterminal angles. That's the next definition we have. Coterminal angles are two angles the same initial and terminal sides. So right here I have my example of 30 degrees. 30 degrees, you'll get really good at graphing. That's a third of 90. There's 30 degrees. If I graph 390 degrees, I have to go all the way around 360 and then go 30 degrees past 360, which means it ends up on the exact same spot. So find a positive angle less than 360 that is coterminal, meaning that they end in the same spot. So this one's 405, and the directions tell us to be less than 360 degrees. So what I'm going to do, you have two options. First, my favorite way to do it is I prefer to graph. So 405 degrees, that's 360 plus 45. So instead of doing the loop-de-loop, how can I get there? Well, if you listen to my words, I said 360 plus 45. So take away the 360 and go directly there. So the coterminal angle would be 45 degrees. Now, the other way that you can do it for my formula people is subtract or add 360 till you get what you need. Okay, so sometimes you have to add and sometimes you have to subtract. For example, on this one over here, if I subtract 360, I'm getting more negative, but it tells me it wants a positive angle. So because it wants a positive angle, I would actually need to go and add 360. But like I said, I really like to graph these, so negative 60 degrees is right there. And instead of going in the negative direction, I could just go 90, 180, 270. If this is 60 degrees, then that little sliver is 30, so 270 plus 30 is 300 degrees. Okay? Let's do the same thing with radians. So just think what's equivalent to 360 degrees in radians. It's 2 pi. And again, it says positive angle that is less than 2 pi. So if you're graphing and you like the graphing method, I'm going to make this 5 pi out of 5. And then I'm going to go 5, 10. Oops, and if you noticed, I went in the wrong direction. I was stuck on the negative, so I'm going to take that out of there, make sure I do it properly. So if I go 5, and then another 5, and then I have 3/5 more. 3 out of 5 is slightly bigger than 2.5 out of 5, because 2.5 would be right in the middle, so it's right here. So the question is how much beyond the 0 did I have to go if I just want to take a shortcut there. So if I just want to go here, that would be 3 pi over 5. Now you might not like that, so you're going to go, okay, cool. I can just take and subtract 2 pi, and then I need to get common denominators because you're combining fractions. So 13 pi minus 10 pi is 3 pi over 5. This one right here, I go negative pi over 15, tiny little sliver. So if I'm there, it comes out like this. Now if that's 15 pi over 15, so I go 15 and I almost go to 30, but I don't go all the way to 30 because there's 1 taken out. So 30 minus 1 would be 29 pi over 15. And again, maybe you're like, not quite there yet in my visual approach. So I'm going to take my number, which is not that, that's the answer. I'm going to go negative pi over 15 minus, I'm actually going to add 2 pi in this situation because I want it to be positive, and subtracting would just make it more negative. So that gives me 30 minus 1, which is 29 pi over 15. Okay, next thing are your conversions. You're going to want to memorize these. These are the ones that you use if it's not a special triangle ratio, which we'll talk more about tomorrow. This just makes your life easier. It's a little bit of stoichiometry, but it's not bad at all. If you want to go from degrees to radians, then you take the number of degrees and multiply it by pi over 180 degrees. And if you want to go from radians to degrees, then you go radians over 180 degrees pi. Yes, you could actually do 2 pi over 360, but of course mathematicians couldn't let that be the final ratio because there's a common factor of 2 in both of those. And then notice degrees cancels out, and these are actually pi radians, so the radian measure actually cancels out as well. So you need that, and your answer here will be in radians, and then your answer here will be in degrees. So our last example just says to convert 13 pi over 12 to degrees. So we do 13 pi over 12. We want to go to degrees, so that means that the pi needs to be in the denominator so that the unit can cancel out, and pi and 180 degrees are coterminal, just in different form actually. So the pi's cancel out there, and then I'm like, oh, I know 6 goes into 12 2 times, and 6 goes into 180 30 times, but then I notice now 2 goes into 2 once and 2 goes into 30 15 times. So the math problem that I have left for myself is just going to be 13 times 15. So you're like, oh, I don't want to do that, but I'm going to do it right here without a calculator. I can actually do it in my head because that's good math for you to practice, but you know, I'm weird. So that's 45. And then we bring down our 0, 5, 1, so that's 195. So we end up with 195 degrees. Okay, so just so you know, the way that you could do this in your head is you do this math. 15 times 10 plus 15 times 3. So the 15 times 10 comes from this part. You're ignoring the 3, so that's 150 degrees. And then 15 times the 3 is 45 degrees, and then you just add those together. And you can do that in your head. I wrote it down just so you guys can see my math. And that's it for today. Have a good night.